The fact that we're trying to combine hydrogen production with chemical production is something that has not been done before. So in that sense, we are creating more value by taking advantage of the byproducts that are produced by the reaction. We're starting from ethanol, so we're producing acetaldehyde or ultimately acetic acid. So the value is not only from the hydrogen we're producing, but also from the byproduct. Another exciting thing is that the fact that we are trying to use both the UVV photons and the IR photons in the reactor, and in that case to exploit the whole solar spectrum. Have chosen to use membranes for separations because they are not energy demanding. So one does not need cryogenic separation or distillation to remove the byproduct or the co-product from the reaction. So in that sense, it is a quite sensible solution to make sure that we actually do not use much more energy than we actually make. We are producing hydrogen and another chemical byproduct, acetaldehyde, or ultimately acetic acid or acetal, which they are useful in terms of a biorefinery potential application. The fact that we're producing hydrogen together with another organic chemical is important for a biorefinery because we're producing not just hydrogen, but also another important product. Something which is important in terms of biorefineries, it has the raw materials, the feedstocks that are used are highly oxygenated. And this is in contrast to normal refineries where the oxygen content of the feedstock is less than 1%. In biorefinery raw materials, the oxygen content will be 20 to 50%. So in that sense, in biorefinery, one has a need for hydrogen to be able to deoxygenate the products. So hydrogen will be a very important raw material for various processes in a biorefinery, and at the same time, we're producing another co-product, which of course has an intrinsic chemical value. For scaling up the technology, important issues that need to be resolved is the robustness of the catalyst and the membranes. The catalysts need to be robust, meaning that it shouldn't deactivate in a short period of time, so it should be able to operate for a long period of time without needing to be replaced. The same thing with the membrane can also potentially degrade during operation because of the organic materials that we are separating. So again, we need to produce membranes that are robust enough to handle the chemicals that we are separating, so that separation should be done continuously over a long period of time effectively and efficiently. The materials that we're producing in this project are unique. We have produced materials which have unique quantum efficiency and unique use of IR photons. And the membranes also we're producing that are unique. So in the sense that they can be used for separations of components that have not been tried before. So people can be excited and use this type of membranes and catalysts, not only in the context that we mentioned, but also in different type of projects.